So my understanding is that we start off with sugar being manufactured in the leaf. People who understand nutrition know that carbohydrates are built out of sugars. So the first thing the plant will do with a series of simple sugars is to build them into carbohydrates. Then you've got your amino acids, and you can build proteins. So the first level of compound in a plant is a sugar. That's a really rudimentary level. If you have the biochemistry functioning, you can build carbohydrates. If you've got the ingredients necessary, the enzymes and the other elements necessary, then you can build proteins, which are more complex, more long chain, more sophisticated. Then you can build lipids, oils, fats, and then finally you build out of one, you build the next. Out of sugars, you build carbohydrates. Out of carbohydrates, you can build proteins, etc., etc. Finally, the highest level of complexity is the phytonutrients, the antioxidants, the terpenoids, the phenolics, the carotenoids, all these things that are fancy, long name-sounding things, which correlate with flavor and aroma and health-giving attribute. So, all the things we call herbs and spices have really, really high levels of these compounds in them, and that's why they have really strong health-giving attributes. So, so the next slide here, slide number 26, is looking at the level of sophistication of the digestive tract of the pathogen. So if there was a bale of hay in this room and someone let the cow in, she would see that bale of hay as food, even though any of the rest of us would have seen it as a seat and wondered why there's a bale of hay in here. Right? This is a thought experiment here, but I think it's self-explanatory. Why is it food for a cow and not food for us? Because she's got 4 stomachs, because she can digest cellulose and turn it into usable energy, and we can't. Right? So what that means by definition is that there's a different level of digestive capacity in a cow than there is in a human. So if you understand that conceptually, think about the level of digestive capacity in the larval form of a cholera potato beetle. Cholera potato beetle, those little red guys with the black spots, right? They don't have a liver. They don't have the enzymes in their gut to digest protein. They're physiologically incapable of it. And so if you've got a plant that is building protein, that is starting with sugars, building carbohydrates, and then able to build complete proteins, interestingly, it becomes indigestible to the cholera potato beetle, the larvae. And this is what I've experienced on my farm since I've been starting to do this kind of stuff, is that the annual war with cholera potato beetles is no longer. I mean, when I was a kid, we would go out with 5-gallon buckets, and every 2 days, we'd just knock the bugs off the plants into the buckets. Anybody else been there? Know about that? Right? I don't have cholera potato beetles anymore. They don't show up. They're not there. There's none to hit into the bucket. There was a couple last year, and I showed my son what they were. He's like, "What are these?" I said, "These are cholera potato beetles." He's a good farmer. He just doesn't know what they are. So what I've got written down here is the level of digestive capacity and the pathogen type. So if anybody's ever heard of verticillium, fusarium, alternaria, pythium, those are all soil-borne pathogens that can digest simple sugars but cannot digest carbohydrates. So when your plant is able to build carbohydrates out of simple sugars, it becomes indigestible too. Pythium, verticillium, alternaria, all those guys, all those soil-borne pathogens. Your plant becomes physiologically indigestible. That's how you do it. When your plant is able to build when your plant is building carbohydrates, it becomes indigestible to them. The larval forms of insects can't digest protein, so when your plant is building complete proteins, it becomes indigestible to what I have written down here. Aphids, cabbage loopers, tomato hornworm, corn earworm, cholera potato beetle, all the larval forms of insects don't have the capacity to digest protein. So your plant becomes indigestible when that's occurring, when protein is being built. The complete lipids, the fats and oils, give the plant resistance to the blights and mildews, the airborne fungal diseases. So powdery mildew, downy mildew, fire blight, late blight, are basically fungal infestations that when your plant is building sufficient levels of oils, it becomes indigestible too. And then finally, the phytoalexins, secondary metabolites, those are the ones that make the plant indigestible to the beetles. So this is what you were saying, Sven, about the when the plant is attacked by an insect, part of the way it wards the insect off is by building higher levels of these secondary metabolites. That will either be a natural occurrence if the plant is healthy by definition, or a crisis response if it's being attacked. Well, it is those things which make a plant taste and smell good, which make it good for us. How's this for a radical revolutionary concept? Right? Your carrot doesn't taste good, your carrot's not good for you. It may be a local carrot, it may be an organic carrot, but if it doesn't taste good, it's not good for you. The carrot tastes good, it may be from California, it may be conventional. It tastes good, it's good for you. It's got the biochemistry in there. The plant had the environment where it was able to go from sugar to carbohydrate to protein to oils to secondary metabolites, in this case carotenoids and things like that, to actually be nutritious. So it is a natural part of the plant's process. In most cases, our plants are in this pre-disease state, and so when they get attacked, they may build a few compounds to be a little bit more resistant, but that's still operating out of a different sort of perspective. Has anybody here ever walked through a patch of basil and rubbed up against it with your leg and had this like hit you in the face? And then have you ever been in the grocery store and you've rubbed the plant that's called basil? Looking for the basil. Is that cilantro or is that flat parsley? I can't tell. I can't tell. I don't know. You can't. It doesn't. It's the level of these compounds that correlate with flavor, with nutrition, with pest resistance, with disease resistance. For me, I don't know if I'm conveying it at all, but it seems like this beautiful order, this beautiful, brilliant system, and that we've evolved to discern. As I understand, a majority of our DNA is designed to facilitate our tongue and our nose's function. Not reproduction, not hormonal systems, not it's our nose and our tongue. It's our sophistication of our nose and our tongue, our ability to sense flavor and aroma, which is our evolutionary process has deemed is extremely important and has given that much DNA over to. I think that's very intriguing. Yeah.